Welcome back. I am Three People. It is the moment that I'm sure all of you have been waiting for. More lessons, more logs. We get to play with our logs today. So last week, I believe that was on Wednesday, we talked about what logs are. They're essentially just exponents. And now we're going to start playing around with them. We're going to start using them and learning about what their properties are. And all those properties have to do with the fact that logs are essentially exponents. Okay, that is the easiest way for me to translate and define what a logarithm is. Technically, they're inverses of exponents, but we're going to treat them like they're exponents because it works all the same. Okay, so here's what we have today, the actual properties of logs. This is a reminder to make sure that you guys focus on this. Logs are exponents. Okay, and just like how exponents have properties, so do logs. So this section here is just a quick reminder of everything that you should already know about exponents and what their properties are. So the first property we have is right here. And all of these exponential properties require that your bases all be the same. So if it's x being taken to a power or 2 or 5, these properties work as long as everything is a base of x or a 2 or a 5 or whatever. So this is the first one. We call that the additive property of exponents, and these x's are the same. You probably remember that when you have two bases being multiplied together, you add up their exponents and write them as a single exponential expression, x to the fifth. 2 plus 3, those are the exponents, added together gives you 5, okay? And we're gonna match these up with the properties of logs, and I'm gonna try to do my best to quickly make sure you guys know what we're talking about. All right, property number 2 of exponents. When you have a power raised to a power, hopefully you remember what you're supposed to do. You're supposed to multiply them, as in, this will be, x is going to be 2 times 3. The new power on x is going to be a 6. And we're exploiting the product property of exponents. And the powers raised to powers times together, and that's your new power. This is the difference property, the subtraction property, the quotient property. It's actually called a few things. And what we're looking at here is essentially as long as you have the same base, if one is in the top and the bottom, remember that a fraction is a nice way of saying we're going to divide these two things. What you do, essentially, and this is kind of in a nutshell, depending, you guys always worry about where the powers are, but essentially what you're going to do is take your top power and subtract your bottom power, and in this particular case, you'll get a power of 1. That is the quotient property or the subtraction property of exponents. This is a fourth one that essentially allows us to rewrite exponents as roots in case we need to do that. And essentially what it says is whatever your base is, this doesn't change, your r is the root index, and your p is the power that either goes there or it goes there. One of those two things. I usually do it where the power is on the end, but you can do one of those two things. So those are the exponential properties that we're going to kind of refer back to as we look at properties of logs. So first thing you need to know about properties of logs is the only way that these things actually work is if our bases are the same, as in the actual base we see in our log is the same depending on which way we're doing these, okay? And these are going to allow us to expand a log expression or condense a log expression, and that's going to make our exponential equations, the hard ones, much easier to deal with. But we have to master these properties first. Okay, so you have to remember, and I always have to make sure I word this right, a logarithm is an exponent. So we have to think about what's going on when we have exponents that are doing this. So we have a log, it has a base of b, and we have two things in the argument here, and they're both timesing together. Well, which of these properties has us starting out timesing two bases together with exponents? The first one does, okay? Property number 1. That's why this is property number 1 for exponents and property number 1 for logs. So what did we do? When we had exponents with the same base and they're being times together, we added their exponents. Well, you get to essentially do the same thing here. I could do a proof for you if you really wanted to. I can do that for you on Tuesday, but we don't need to. We have multiplication. You can expand this logarithm out by writing it as 2 logs with the same base. They're both a base of b. And one of these logs is going to get x, and one of them is going to get the y. Now we have expanded them, but we have to justify them. We don't just leave them like this. So what did we do when we had two bases being times together, just like kind of how we do here? We added them. Okay? So this actually means two things. This means if you see something in your log that's being multiplied and I ask you to expand it, this is how you do it. You separate each of these arguments into two separate logs that are being added together. Now, the flip side of this is if you see two logs with the same base being added together, what that's really telling you is that both of these arguments can be written as a single log with multiplication being done to them. Okay, and you're going to see that kind of happen across all of these. All right, property number 2. A log is an exponent, and it's being taken to an exponent. Well, just like property number 2 in exponential expressions, when we have powers raised to powers, we times them together. This one's a little harder to show, so I'm just going to kind of write it like this. We get to do this. We get to say, well, this property of y, we can put it in the front, because this is an exponent right here being raised to another exponent, just like these guys here. What do we do with those? We times them together. And the real trick is, if you see an exponent on your argument, stick it in the front and rewrite it as a single log. Some people do it in parentheses like that, some people don't. Now remember, all of these properties are essentially showing you two things. If it's a simplified form, as in it's written as a single log, you can expand it out. This is going to be a huge factor in our exponential equations that we're going to start solving later. If you see an exponent here, it belongs in the front. On the flip side of that, if you see a number timesing in front of your log, you can actually replace it if it helps you for whatever reason and stick it back up here on the argument in its own exponent. And we're going to see some examples of that in a little bit, but that's essentially the next property we have. Now you might have guessed it, when we had two exponents and they were being divided, we subtract their exponents. Here we have two arguments being divided, and the log property here that matches the exponent property here says you can split this one up as long as it's log of the same base. But this has to go in order. Whatever was in the top goes first. Whatever was in the bottom goes second. And how do we have to connect these? Well, when we divided them, what did we do? We subtracted the exponents. And again, remember, this is saying two things. If you see a fraction in a single log, you can split it up into two with subtraction between them. Or, if you have two logs being subtracted and their bases are the same, you can put them into a single log as one big fraction like this, x over y, or whatever these arguments are, top over bottom. All right? And we're going to talk a little bit about how to simplify that too. Number 4, down here. This is what we call a change of base formula. It's kind of like changing an exponent into a root expression in case we need to. You are definitely going to need this, especially if you don't have a Casio. Okay? Now, I did not bring my Casio home today. I have my TI. So I, in fact, need to use this when I ask you guys to evaluate these things. So here's essentially what a change of base formula allows you to do. And I'll explain to you why we need it as well. All right? Good. Making sure I got everything. Okay. Let's pretend for a minute that this base is not one that we can use. As you might have seen on your calculator can only do bases of 10, or e. We didn't talk too much about that, but they can only do, for sure, bases of 10. If I have you evaluate a log, and it's not in a base of 10, you're going to have to change it. So here's what you do. You're going to put it in your calculator. You're actually going to use parentheses for all this. Choose the base that you want. It goes into both of these, all right? But you're going to take this top log and divide it by this bottom log. The argument that goes here is going to be the original argument that you had. Okay? The argument that goes here is going to be the old base that you had. This will be an equivalent expression that allows you to go back and forth between a base that you don't like and a base that you do like. Some people have a better time seeing it written this way, in that it's log of your new base of your old argument divided by, and this is what you're going to type into your calculator if I ask you to do it, divided by log of your new favorite base that you wanted to choose of your old base that you changed. Okay, so this is essentially what goes in to your calculator if I ask you to do these, all right? So we're going to have to kind of deal with those in a little bit. This is also huge. It's not necessarily a property. It's the definition of what a log is. It's a rewritten exponent. You have got to be able to identify exponent form and log form, and you have to be able to go back and forth between the two. If you can't do that, you can't go back and forth between the two, your exponential equations are going to be extremely difficult for you to try and solve. So these are your properties that you guys need to know. Hopefully you guys don't forget those. Now we're going to focus on the skills that we're going to use. We actually have 3. I wrote down 2, but we actually technically have 3. Just one is an evaluation that you guys are going to have to do. So here's what this is going to look like. Okay. So we're going to focus on 2 skills, and then we're going to look at essentially, yeah, you guys can see that. Okay. So we're going to focus on these 2 skills first, and then we're going to show you guys how to evaluate logs that have bases you don't know how to use, all right? I was giving you guys evaluations that are super easy that you can do in your head. Not every log is like that, so you guys are going to have to come up with these on your own. Okay, the 2 things you're going to be asked to do, either expand your log or simplify, sometimes we say condense your log, all right? The real difference is expanding your log is when you want to write it in as many log expressions as possible. Simplifying your log means, if you can, write it in a single log expression using these properties. And these are going to be tricky for you guys to get a hang of. I am expecting a lot of you to come to me on Tuesday for Zoom session to try and get some of this down. It's not that bad when you see some examples, so pay close attention, rewind this if you need to. You guys have got to make sure that you know how to use these properties. So we're going to start with the expanding part of this, which is this guy, okay? Now, sometimes I can give you arguments that have powers on them, and you can actually do a couple of things with them. But exactly like you guys think, this is an exponent on both of these. So the first thing that I would do is I would rewrite this with the new exponents on my arguments, my a and my b. The exponent on a is 2, it's being times by 6, so the new exponent is 12. The argument on b has an exponent of 1, and timesing 1 by 6 will give you a new power of 6. But this can be expanded more. There are 2 things inside of your argument here. What do our properties allow us to do when there's multiplication in your log? We can split it apart. So this is the next step. We can split it apart using the same base with A and its power and B and its power. We just have to make sure that we put addition between them. Now, when you guys are first trying these out, you're going to think, well, that's odd. Why is he leaving this like this? Am I done? And the problem with these is you don't really know for sure. My only real trick I can give you for expanding is make sure that there's not a lot of powers, like exponents or superscripts, but make sure that all your bases are the same. So the next thing we do is we go, all right, are there any other properties that we can apply to this? Well, A has an exponent of 12 and B has an exponent of 6. This is another property that we can exploit. What do you do when your arguments have powers on them? Well, you take the powers and you attach them to the front of your log with multiplication. So we're not done rewriting this yet. Here should be our last step. This first log is going to be 12 times log base 4, that didn't change, of A. There's no more 12 on this A because I took it and moved it in the front. There is still addition between them. And my next log is going to say 6 because there was a power of 6. Log base 4, but this argument was b. Now you're just going to look one more time. Is there any other properties that I can exploit? Do you see any fractions here? No. Do you see any multiplication happening inside of your argument on your log? No. Are there any other powers that we did not deal with? No. This is fully expanded using our log properties. Okay? Great. Number 2. This one's a little bit trickier. In fact, there's a couple of things going on here. Look at what we have. We have a single log with a base of 2, so whatever we have at the end of this, we should be using a base of 2. And we just need to split this up into as many log terms as possible. That's what expanding allows us to do. And I know you guys are thinking, why would I ever need to expand it? It's going to make our life easier for when we start doing exponential equations. If you don't know how to expand, it's going to be tough for you. So we're looking here. Well, this is a big fraction. What do we do with big fractions and log properties? We split them up. Log base 2 of x to the third that's in top, and another log base 2 of the stuff that's in the bottom, z, y to the 6th. But what does the property tell us to do if we're going to split up a fraction? We have to put subtraction between our two logs. That is what the property says, and that's what you guys are essentially going to be asked to do. Now, we're not done. All right, this one might take a little work for us to get there. Okay, so they're not going to be easy. You guys are going to have to get used to that. First thing, I see a power right here. Well, where do powers belong if we're expanding them? They belong in the front. So this first log is actually going to become 3 times log base 2 of x. And we're going to have some subtraction here. But how are the z and the y arguments stuck together? They're in a parentheses, they're in the same argument. We're actually going to be able to expand this as well. How do we expand these? We would expand them using our additive property, but they were both in the denominator of a fraction. So am I subtracting part of this log or this entire log? I'm subtracting the entire thing. So how am I going to write this? I'm going to keep it as subtraction, log base 2 of z, he didn't have a power, minus log base 2, still, of y to the 6th. Now, why are both of these subtraction? Well, the z and the y were both in the bottom. Anything that's in the bottom has to be subtracted. Okay, so we're exploiting all these properties still correctly. Are we done? No. We still have an exponent on our argument of y. Your job is to make sure that that argument has no powers on it using those properties. So where does that power belong? It belongs in the front. So we have to write it one more time. 3 log base 2 of x minus log base 2 of z minus, stick the 6 in the front, 6 log base 2 of y. Now we have expanded this as far as we can. There's no more powers, there's no more arguments that are stuck together. That is what you guys have to do for number 2. Okay, and you guys are going to see a lot of these, so my advice would be try your quizzes once or twice, however many times, really doesn't matter, and then come see me on Zoom if you don't know why you're getting certain ones wrong or if you're totally lost. These are not easy, so don't beat yourself up if you think that they're easy. And for those of you trying to do this on your calculator, you can't do it. Okay, you can't do these on your calculator. You have got to be following the procedure. So I should see a lot of handwritten work, especially for those of you that are requiring you to have handwritten work. So number 3, here we go. A lot of people get stuck on this one. There's a big square root here. Well, Wally, you didn't tell us how to deal with square roots. You're correct, I did not. But you have to remember something about square roots. No, do not do that. Okay. You have to remember something about square roots. A square root can be rewritten as a power, but it's a root. I know. How does a square root get written as a power? It's not a power of 1, it's not a power of 2, it's a power of 1/2. The 12, the 5, and the 11 were all inside of the square root, so the 12, the 5, and the 11 should all have a power an exponent of 1 over 2. That's a power of 1 because there's no power on them, and a root of 2 because they're in a square root. Okay, so a lot of people are going to forget that. Now, you have a couple things you can do here. I like getting rid of the exponents right away. I can show you kind of another way to do it if you want. I'm going to stick with this here. We have not expanded these yet. They all have a power of 1/2 on them. And they're all multiplied together in the same argument, okay? This is all multiplication. There's no division of multiple terms like there was in number 2. So how do we split up multiplication? Even if it's more than one term, we split it up by writing 3 different logs, or 3 logs with the same base, and putting addition in between them all. What's this first one? It's going to be 12 to the power of 1/2. What's this second one going to be? It's going to be 5, also to a power of 1/2. What's this third one going to be? It's going to be 11, also with the power of 1/2. All right? We are not done yet. I know that you want to be done here, but we are not. All of these are exponents. When you are expanding them, where are exponents supposed to go? They're supposed to go to the front. Okay, just like that. So this log right here, we got another line, is going to be 1/2 log base 3 of 12 plus another 1/2 from this one, log base 3 of 5 plus another 1/2 log base 3 of 11. Okay, now technically this is okay. All right, but I have to show you this next step that kind of makes it look different. It's not an actual step you would necessarily have to do, but it's going to help number 3 make a lot of sense. If I'm timesing all of these by 1/2, it is exactly the same thing for me to write all 3 of them as fractions with 1 in the front and 2 in the bottom. 1 in the front, 2 in the bottom. 1 in the front, 2 in the bottom. That's how we show you that we have fractional products in a log expression. So these will take you guys some time, all right? So I know that they get confusing. I'm expecting to see a lot of you on Zoom. Please make sure that you guys are checking these out. And I'm hoping that you attempt them more than once, okay? All right, simplifying, condensing. Well, this is essentially the exact opposite of what we did on the left side of the board. You have to look at all of these, think about what your properties would have made you do in expanding, and get them back to a single log. You guys have to be able to go back and forth between these properties. If you can't, it's going to be kind of tough, okay? So here's where I start. Do we have any numbers in front of our logs? Yes, we do. We have a 2 right there and an 8 right there. Where did those numbers come from if we were expanding in the first place? Well, where did these numbers come from? All right, where did these numbers come from? They would have been up here in the powers. Okay, so the first thing I'm going to do is I'm going to rewrite log base 8 of 10 with its power, 2. Still plus, I have not dealt with what that says. Log base 8 of 11 with his power of 8. Okay? I don't see any more numbers in front of my logs, so my next step is to think, all right, I still see 1, 2 log expressions. They are separated by addition. Well, if we're going to split up a log and we put addition between them, what did we have there before? What property is that? The first one we looked at. These logs can go back together as long as we multiply their arguments. So check this out. Now we're going to put this back into a single log with a base of 8 and one big giant argument that has 10 squared times, because we had addition between our logs, 11 to the 8. Okay? I know this looks gross, but I only see the word log, base 8, written once here. You totally are welcome to. I'm not going to require that you do. You are totally allowed to multiply all this out and get a single number here. but this is essentially our simplified version of that expanded log, okay? I'm going to try and make it a little quicker for you guys on number 2. We've been doing these pretty by the book, so let's just kind of see what we do. I'm looking for numbers first, all right? No number here. There is a 6 right here for number 2. There is a 3 right here for my last log. There's a negative in front of that. Don't worry about that. We're going to take care of all the addition, subtraction after we deal with our numbers. So where did the 6 and the 3 come from? They would have been exponents on our arguments before we expanded them out. So this log didn't change at all. Log base 8 of z. There were no numbers in front of this thing, so we just leave it exactly the way it is. This next one, the 6 is not in front of the log anymore. It's back up here on the exponent of the x, okay? There's still subtraction between these. There's not a 3 anymore. There will be a log base 3 of y, and his new power comes from the 3 that was in the front, okay? Now here's kind of the shortcut looking at these logs. Any log that's positive means that they can go together with multiplication. Any log that's negative means that you had some subtraction. You had a fraction that you split up before. So here's how I do this. It's going to be a lot quicker for you. I'm going to write all of these in a single log, base 8. This guy and this guy are both positive. This one is negative. That means we have a fraction as our argument. Well, since these guys are positive, one of them is going to be z, one of them is going to be x to the 6th. Since this log is negative, the y to the 3rd is not going to go next to this x to the 6th. The minus sign means that it belongs in the bottom of a fraction. It should be y to the 3rd in the bottom of our fraction, just like that. So you guys had one like this on number 2. The x cubed, the z, and the y are all part of this. The x is the only one that's positive. These two became negative. Same idea here. There are shortcuts to doing these. After you do about 5 or 6 of these, you might be like, I can do these in my head almost and get straight to the answer. If you can do that, that's great, but I'm still going to require that you show me the steps in between, okay? Last one, okay. Holy crap, Watley. Oh shoot, I shouldn't have sworn. Whatever, it's on the tape. Goodness gracious, Watley. Why are these fractions? Think about it, guys. Why are these fractions over 2? They're fractions over 2 because what was the number in front of all of these logs? The number was 1/2. I do have a number in front of this one, but I'm going to worry about this fraction stuff first. So check this out, okay? I'm going to keep this guy. I'm going to have to erase this. I'm going to keep this guy the same, 5 log base 6. But what was this log stuff over 3 before we changed it? It would have been a 1/3. Just like how these ones were 1/2. Okay, like this. Same with this one. That is a log over 3. So what number should be attached to our log if we were to write it out? A 1/3 is. Now I'm going to start looking at, okay, do I have numbers, even if they're fractions? Do I have numbers in front of my logs? Yes, I do. Where should they go? Back up into the top of the argument in its exponent, where they would have come from if we were expanding. So here we go. Log base 6 c of 5 plus log base 6. Notice there's no more numbers in front of these logs anymore. Of a to the 1/3 power, because that's what was in front of this log. Plus again, a log base 6 of b also to the 1/3 power. Okay? All right. Now the next part of this is we're going to see, can we condense them all into a single log? We put the powers where they're back where they came from. We just need to condense these things so that we can actually write it as a single log. Well, positive, positive, and it doesn't show you, but positive here. When we have positives in front of our logs, what does that mean? How can we put these logs back together, or where did they come from? They came from a bunch of multiplication that we had before. So we can actually write all of this out as a single log, base 6 of c to the 5th times a to the 1/3 times b to the 1/3. That looks like a single log to me. You're basically done. This would be an acceptable answer if you guys were taking tests with me like you would normally using these log things, and you know, you would have been fine. But you're gonna have to know how our computers, how our programs are gonna rewrite this. See how both of those, the A and the B, have a power of 1/3? Think back to this. Why did all of these have a power of 1/2? What were they before? They were in a root. So you're actually gonna rewrite this again, or you're gonna have to recognize that you have A and B in a third or a cube root together, timesing onto that c5. So this is okay. If you can get to here, you're in good shape. You're just gonna have to recognize that that means the same thing. Okay? It's gonna be a long video, I can tell. All right. Now, one other thing that I have to show you how to do. I have to show you how to use the change of base formula so you can evaluate them in your calculator. And yes, you do have those. I don't know if it's 1 or 2 separate quizzes, but you do have them. So here we go. We're going to watch out for it. This is going to be kind of a little bit of a dense day. All right? So you guys are going to have to make sure that you're becoming masters at all this log stuff. Okay? All right, here we go. I'll be posting pictures of the notes. You should see them below this video anyways, including the steps on our example problems. Please make sure that you guys show up to our Zoom session if you're confused. I can't help you if I don't know that you need help. Okay, so here we go. I am also going to ask you guys to evaluate things like this. Okay? Now, you have to have a calculator for these questions. So once you, as soon as you guys start your quizzes, have your calculator handy. All right? You got to be able to do this. Now, you might notice, back when I first taught you how to evaluate these things, you just had to ask yourself this question. What power of 2 gives you 37? Here's the problem. Is there a nice power of 2 that gives you 37? No. But there is a power. It's going to be a weird fraction or a weird decimal. There is a power of 2 that will give you exactly 37. Okay? I know it seems funky, but it's the way that these exponents work. You guys are used to them only being integers. They can be decimals now. If you have a Casio, you can essentially type this in exactly the way that you see it, get your answer, and you're done. If you're like me right now and you have your TI, you can't. Okay? So what we're going to use is we're going to use our change of base formula. The change of base formula is essentially a bunch of division that we put into our calculator that's the same as this expression in the beginning. So I'm going to write it like the change of base formula, and then I'm going to show you how we actually plug it in to our calculator, and then tell you when you're going to push enter on your calculator, assuming if you have a backwards calculator, it's going to be really hard. Please, please, please go to Walmart, Target, whatever it is, and get a calculator that's scientific. It does not have to be this one. This is a $100 calculator. You can do it with the Casio. You can do it with the cheap TI. But make sure it has that button right there that says log on it. I'm sure that you can't see it, but that's the one. So our calculator allows us to do log base 10. We can't do a base of 2. So we have to use our change of base formula. Well, what base do we want to use? We want to use a log base 10. Why didn't I write my base? Because when we don't write it, we assume it's a base of 10. We are choosing to use a base 10. So all that you're going to have to write on your paper is log of the argument over or divided by log of the old base. This will get you a power of 2 that, when you do it, gives you 37. Now, what do you type into your calculator? You type this in. You hit the button that says log. 37. And this, sometimes it's going to open a parentheses right here. Probably will. Make sure that you close it in that next step. You're going to hit the divide button. Hit the log button again. Log of 2. Don't forget to close that parentheses. As long as that's what you type into your calculator, log 37, close parentheses, divided by log 2, close parentheses, enter. And I usually have you guys go out to about 4 decimals here. This is equal to 5.2094. I'll give you them all. 53366. Okay? Now you can actually check this. You can go back into your calculator and you can take 2 to this power, 5.2094, blah, 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 and you will get 37. It's freaky, but I'm telling you that all of this is connected. This is a way for you to check. If you don't get 37 or very close to it, because this decimal goes on forever, you might be doing it wrong. So that's what you're supposed to do on these types of questions. I'm going to ask you for the value of this log. You have to use a change of base in order to get there. Okay? How about this one? What power of 3 gives you 50? Okay? And you can kind of try to guess, right? A third power of 3 gives me 27. A fourth power of 3 gives me 81. I am expecting this to come out somewhere between a power of 3 and a power of 4, or an answer of 3 and an answer of 4. That's probably where this is going to end up, okay? But we can't evaluate it and give ourselves an exact answer, so we're going to have to use a change of base formula. What base are we going to use? The only one that your calculator allows you to use, unless you have a Casio. We're going to use a base of 10. We're not going to write the base of 10 this time because we're big kids now, and we want to make sure that we are using the fact that is a common log. We're using base 10. The argument starts it. The old base finishes it. So what do we actually type into our calculator? Log, on your calculator, of 50. Close parentheses. Divided by log of 3. Close parentheses. Hit the enter button. And like I said, I have not actually done these already. I'm sure that you're not going to believe me, but I have not actually done these. I made these up on the spot. I'm expecting this to be somewhere in between 3 and 4. Look at that. 3.560876795. I'm only going to ask probably that you guys give me those 4 decimals, but that is what we are looking at. This is our power of 3 that gives us 50. And you can check it if you want to. Take 3, take it to that power. So you can do 3, power, answer button on your calculator, and it'll spit 50 right back out. Yes, you can get 50 by timesing 3 by itself a bunch of times. You're just not going to times 3 by integers of itself. You're going to times it by a decimal of itself. I know that seems weird, but trust me, that's the way that it works. Okay? So, that is how you evaluate them. This is going to be quite a long video. I hope that you guys are still with me. I hope that you don't mind. Please come to me with questions. I will post this as early. You know what? I might even post this tonight. It's Sunday, so it's Mother's Day. So I might even just post this tonight so that you guys can start looking at it, because this is not an easy topic. As soon as you guys see this, start looking at your quizzes. Watch it more than once, especially the examples. Learn how to expand, condense, and base change as needed. Have your calculators handy. I will see you with all of your questions on Tuesday at 11. See you later.